Hi everybody, welcome to week 5. This week we're going to look at how information is produced, particularly in a digital context, and how the production of information and information management practices are actually very closely intertwined. And we have 3 things to look at in the lecture today. We're going to look at the history and development of computer-based file systems and management practices for ensuring effective use of a shared file system. We're also going to look at the file system lifecycle and how files have their own very low-level life cycle from production to use to preservation that runs separately from the other types of information life cycles that we've looked at previously. The third thing is we're going to look at how files can be designed to be more effectively used in information production, which is a topic that very directly impacts information management. Now let's start by talking about file management practices. File management is a very low-level activity in an organization, and you have to think about it kind of in terms of how organizations used to record and file information before the advent of computer systems. If you look at movies from the 1930s and 40s that depict people working in large business organizations, you'll notice that they have hired an army of clerks, and they have large filing centers and filing rooms where these clerks are constantly running back and forth with paper documents that need to be filed and maintained for the company. Well, we produce just as much, if not a lot more, information in today's business and organizational worlds. However, we don't need an army of clerks anymore. With digital information systems, the lowest level of document is certainly a data file, but we still need good management practices to keep those files in order and accessible to users in an organization. So certainly the benefits of maintaining good file management practices is that productivity within an organization is improved. Certainly data retention is improved. And we find that content is reused more frequently. Good file management practices also positively impact IT resources, in that networks and servers can be balanced and not overloaded when files are managed appropriately. Now, poor file management practices in organizations that don't manage their data files on a regular basis, we find that there's a lot of content loss and a lot of content recreation instead of reuse. This is a view of what the file management lifecycle looks like, and we'll examine this in more detail as the lecture progresses. The main thing to remember is that there's 3 stages in the life cycle of files. There's production, product, and preservation stages. And each of those stages has its own phase of development, from design to creation to management. Now, a computer file system, whether it's on a server, a shared file management device like a portable hard drive, or on a personal laptop or desktop workstation, is the entity in your operating system that allows for the permanent storage of data and resources for a computer system. And we usually refer to permanent data storage in computer systems as mass storage, which can be disk, tape, or now solid-state drives. Now, every computer system has a file system that helps manage the mass storage, and it also has a file management system, which is what the end user operates in order to move, modify, and delete files from the file system. So those are two distinct services. In the early years of computing, the file system was managed by a very low-level, kind of primitive part of the computer's operating program. And the human beings who operated the computer systems actually had to know a lot about how the computer systems' storage resources were laid out in digital terms. In today's operating systems, disk management is performed largely behind the scenes, and you as an end user have fairly minimal interaction with the file management system. And certainly since the 1980s, we've seen the development of very sophisticated, rich content, easy to use, visually oriented file management tools for computer users that have become integral parts of a graphical user interface operating system. Now here's an illustration from 1962 that shows an early form of, it would actually be a mini computer instead of a mainframe computer, but that was actually in use for a large banking chain at the time. And this system would be used at a major city branch of the bank. You'll notice in the top left corner that there is a primitive disk storage unit. However, this bookcase-sized disk storage unit probably held less than a gigabyte total of information, which we can compare to today's off-the-shelf laptops and PCs that have terabyte-sized drives. Below the disk storage unit, you also see what was in the 1950s and 60s the most common form of permanent data storage for computer systems, and that was a magnetic tape reel. These were not very portable, the magnetic tape reels. I mean, you could ship them at some cost and risk of damage. And magnetic tape reels didn't actually have a file system that managed where data was stored on them. Data was stored actually in a sort of a linear manner, and the program that was storing the data on the central processing unit would simply mark the start and end points of a stream of data that was to be stored on tape. So there wasn't a file system that a human operator could look at to be able to retrieve files, and the programs that were run on these computers were actually had to know a lot about where the data that they needed to use was stored, which is quite a bit different from today's application programs. A major advance in file system evolution came in 1969 when Ken Thompson and Dennis Ritchie at AT&T Bell Labs developed UNIX, which was the first modern operating system for a server, computer server. And one of the components of the Unix operating system was that it provided a very simple text-based file management system that users could interact with in order to create modify, delete, move, and organize files on the server. The operating system was also a great advance because it was designed to manage all of the functions of a computer server sort of automatically and in the background. So a lot of file management functions that had to be run by specific application programs in the 1950s and 60s could now be maintained automatically by the computer operating system. Now, in the late 70s and early 80s, we saw the advent of the personal computer. This is actually a set of pictures of the first personal computer that I learned to use. It was called a Commodore Plus 4, which was a sibling of the more famous Commodore 64, which was not much of a computer by today's standards. It had a whopping 64 kilobytes of RAM on the system. It had no internal disk storage. Storage was managed by the floppy disk drives, which you had to have at least two hooked up to the computer, one to run your application program and then the second for data storage. And when you wanted to save or retrieve a file, you actually had to know quite a bit about the block sector layout of the magnetic disk on the floppy drive in order to be able to find and load or find an open spot in which to save an application file. Now, Commodore had its own operating system with a very primitive UNIX-like text-only file manager capability. The next step in evolution in personal computing file systems was Microsoft's MS-DOS. DOS stands for Disk Operating System, which was designed to manage a hard disk drive instead of simply a floppy drive. And at that time, the method of managing hard disks was a technology that's actually still around today. It's used on flash drives and portable hard drives quite a bit. But it's a fairly inefficient disk management system called FAT, which stands for the File Allocation Table Method. And IBM originally adopted MS-DOS for use on the hardware that it was selling, the personal computers it was selling. But Microsoft and IBM had a falling out, unfortunately. And so IBM developed its own variant of MS-DOS, which they called PC-DOS, which is essentially very similar. And quite separately from Microsoft and IBM, Apple developed its own operating system, and its early disk management system was called HFS, still a technology used today. And in fact, it's quite closely related to the original UNIX disk management system. And part of the HFS, the original HFS disk management system, is still in use today in the Mac OS, even up to OS 10. Later in the 80s, we saw the development of graphical user interface operating systems that had fairly sophisticated file manager tools available so that you could visually see and move files around a disk and organize them, and there were a number of different sorting and grouping and organizing features that started to appear in these file managers, both for Apple Macintosh computers and for Windows PCs. This slide shows Windows 1.0, which was on the right-hand side, which was a bear to use as both for file management and for as an operating system. And then its more popular successor, Windows 3.1, which some of you may have had experience with. Now, while Windows and the Mac OS were developing, there were also several variants of the graphical user interface operating system that were being developed. The first one was a GUI interface for Unix systems that was called X Windows. You can still find that around today. But it was primarily used in the university computing environment and by more technical users. IBM also tried to develop its own graphical user interface operating system called OS/2. And it was interesting, that was also an IBM and Microsoft collaboration. And early in the 80s, they had yet another falling out. And so IBM continued developing OS/2 on its own up until around 1995. The last commercial version of OS/2 was OS/2 Warp. And I mention it just in historical terms because it had excellent file management capabilities and was actually quite a pleasure to use as an operating system. And it's too bad it wasn't continued on as a competitor for Microsoft Windows. Now, the latest versions of the three most popular personal computing operating systems have really souped up their file management capability and have a lot of interesting and even sometimes useful tools that have been added on to the file managers to make file management less of a chore and more of an enjoyable user experience. But all three operating systems shown here have quite similar capabilities in terms of file management and quite similar fun end-user tools for file management. Some of the characteristics of the most current operating system file managers include that how you look at files on a computer system are not solely dependent on your physical storage media anymore. There's lots of capabilities built into Windows and the Mac OS especially to create virtual folder and file representations. File systems also have a great deal of metadata capability built into them nowadays, which takes the form of extended file properties for files and directory properties for directories or folders. And again, there's a number of visual tools for naming, managing, and moving and organizing files on the file system. Now, there's some great benefits with some of the new features that contemporary file systems provide that you can use to enhance the documentation and organization of files that you manage. There's also some limitations to these. Using extended properties in files in the operating system can certainly enhance your retrieval. This is certainly the case in Mac and Windows PCs, and can help you better document the files with information about things like the status of the files and their content and where they belong in a file system organizational structure. And you can also use simple tags to very quickly assign statuses and properties to files. And these, again, are very useful, and if you're in a computing environment that supports these, you should go ahead and use them with the understanding that there are some limitations. Some extended properties are only visible to certain applications. So for example, if you load up a Microsoft Word document with a lot of metadata and extended properties, you'll be able to see and use that metadata in Microsoft Office applications, but you certainly wouldn't be able to see most of that data if you open the file in OpenOffice or another set of Office applications. And also, extended properties can also often get lost once the files are moved out of the directory in which they live. So if you're copying files from a file server to a thumb drive, or if you're sending them an email or sending them across the network, moving them across the network, oftentimes these extended properties won't survive. They'll get stripped out of the file. So they're only really useful for files that move around on one home disk or disk array. So as I said, do take advantage of new file system management tools that are available in the most contemporary operating systems, but be aware of their limitations. When you're working in an organization with other people especially who are creating and using files off of shared file storage areas like file servers and portable hard drives and so forth, it's important to enforce some rules over how the files are managed, how you organize the files, how you name the files, etc. And unfortunately, you as the information manager are often going to be, by default, the police officer that performs these enforcement procedures. Now let's talk about file naming conventions. How files are named is extremely important for easy retrieval of the files, especially if you've got directories full of end-user files. I'm working right now in my day job as a librarian at UNM here on the archives of one of New Mexico's senators who's about to retire, and his office has extensive shared file system and literally thousands of user files that his staff have created. And there wasn't a great deal of enforcement over the rules of how files were named or organized. And so a lot of time is being wasted as we look at the material to try to figure out whether a report or a speech that's on the file system is the final version of that document, if it's was a draft, or if it was actually ever used. And we certainly are having a hard time figuring out who wrote the documents because of the lack of metadata documentation. And part of this all goes back to having some basic file management practices in an organization that were routinely enforced. So file naming conventions are extremely important. People like to sort of groan and roll their eyes when you talk to them about making sure they use the organization's file naming rules, but as I just described, they are extremely important rules to have. There's 5 major types of file naming conventions. You don't have to use each type as a sole individual method of naming files. They can actually be mixed and matched, as long as they're done so in a systematic and documented way, so that people who create new files know how to implement the file naming conventions. So we have abbreviated files and named files. And this sort of practice goes back to the old days of MS-DOS, where you had the old 8.3 file naming limitation, where you could only have 8 characters in a file name and you had 3 characters for the file type extension. So developing a good abbreviated naming system helps keep files shortened, file names shortened. File names can also have mnemonic characteristics. Here we see where annual report has been shortened to two character keywords, and the date elements of the date and version elements of the file name have been abbreviated in a standardized manner as well. With contemporary file systems, you don't have as much of a limitation on how long a file name can be, so having rather long descriptive file names is certainly a practical possibility. Here we see a classified file name where the file name has been designed to sort properly when the file is placed in a directory with many other files. So the classified file name shown here, all of reports in a directory will sort together, and all annual reports will sort together as a subgroup under reports, and all annual reports from 2012 will sort together as a third subcategory. Certainly adding a date to a file is important to indicate its creation date, especially because the date on the file system can be distorted either by human beings or by programs and the operating system. So that's not always a reliable indicator of actually when a file was created. A lot of times in Windows file systems, if you move a file from one server to another or from a file server to a PC, the created date will actually update as the date that the file was moved rather than the date the file maintaining the date the file was created. And then another important thing, especially in an organization that's producing information and versions of documents, documents may go through several different versions, before they're completed. So marking files as being draft 1, draft 2, or final is certainly a helpful indicator that you can use to mark files as being complete or incomplete. Now, directory management is the other major activity in overall file management. And it's important in an organization to have a standardized set of concepts as to how directories are going to be arranged to organize files. A lot of times, if you give 100 different people the same set of 100 files and ask them to create an organizational structure for those files, you're likely to get 100 different sets of organizational methods. Organization is a matter of preference, and it's highly subjective in terms of an activity. So it's important to standardize how your directory structures are going to be organized. And some ideas here are to organize them by subject topic, to organize them by document type, by date of creation or completion, and to organize directory structures by status, by whether documents are in process or final and ready for use. It's important to create documentation about your directory structure rules and to make sure to train the users. That's the other aspect of file management for an organization that often falls on the information managers, is to be the default trainers, to tell the workers at the organization how to follow the rules and to implement file naming conventions and organizational procedures effectively. The other main issue with organizing file structures kind of goes back to library science classification theory. When you're organizing a lot of information, we tend to want to look at how well the organizational structure is maintained in terms of its depth or its breadth. When we have a broad organizational structure, this is actually good for browsing subject topics in a directory structure. It's not so good for other types of hierarchically maintained information. But a broad organizational structure treats all the subtopics under a main category as equal partners. So here we see our main category is the subject topic of art, and its subtopics, which are all treated equally, are sort of the media or subdisciplines within art: drawing, painting, sculpture, etc. The problem with a broad organizational structure is that once you get more than 10 of these subcategories under any main category, it starts to become rather tedious and cumbersome for users to sort through all of the subcategories. So it's important to design a hierarchical structure of directories that are broadly organized to try to keep them between 5 and 10 subcategories. By contrast, organizational depth continues to subdivide information at lower and lower and more specific levels, so that files that cover very broad topics tend to be at the top of the organizational ladder, and files that deal with very specific topics tend to be several levels down in a subfolder organization. This is appropriate for very hierarchically organized data, but the problem with a deep organizational structure is that, again, it becomes hard for users to browse this structure beyond 2 or maybe 3 at the most levels of specificity. So if you're going to organize a deep folder structure, it's important to maintain just a couple of levels of subdirectory organization underneath it, so that you don't wind up losing data, or data becomes missed because it's simply buried too deeply in the hierarchy. Now, in the early days of personal computing, files were pretty simple objects. You had applications that generally produced one or two types of files as their output. Maybe in terms of like an Office application, you had a document type of file output from a word processor, and then maybe you also had a template type of output from the same program, and that was about it. And the files tended to be fairly simple and easy to understand. Today, many applications, especially more sophisticated applications that are used in production of content and in research, produce very highly complex digital objects as their output. Now, sometimes in the case of graphics and certain types of analysis programs for research, those documents can be single files that are actually very complicated containers of other types of information. However, more and more we're seeing that complicated applications produce as their output for one project multiple files, and those files often have to be organized in a directory structure that that application can understand. This is certainly true for programming applications like Visual Studio or Eclipse that are development environments for programmers to write computer programs, and it's always sort of been the case with that niche of applications. But also multimedia applications such as video, digital video editors, audio editors, and graphics tools often produce multiple file sets of objects, and those files have to be maintained in a certain order. So you have to take this into consideration when you are archiving these complicated digital objects, that they need to be sort of wrapped up in one larger container, and that container is what needs to be moved around to keep all of the pieces of the digital output together and understandable by the application, so that the objects can be opened by the application that produced them later on. Now the container files, a couple of good examples of those single file containers of complex data include Photoshop and Acrobat PDFs. Compound objects is what we call the more complicated multi-file output from applications. And you'll see these two terms variously in the literature about managing digital assets. So now that we've talked about file management practices, let's move on to examine the file production lifecycle that I mentioned earlier in the lecture. As I mentioned, there's three major life stages of file production and use. And like I said, we're talking about file level life cycle as opposed to the content level life cycle that you all studied in, I believe it was week 2. But there's the three major stages that data files go through. First, the files are in production, so you don't usually start with a finished file. Usually when you're producing information, even something like a term paper for a class, you usually have several different files that go into your final product that will be a file, but it'll be a product file instead of a file that's an element of that product. Product files are the finished versions of the content, and they are what are distributed electronically to distribute the content. And then once the life of the product file ends, it can optionally be translated into a preservation file, possibly by changing its format into something more open source. Preservation files can also be used to capture other types of content directly. So here in the life cycle diagram, we see the three major stages of file life, from the production stage to the finished product stage to the preservation stage. Now, not all finished products move into the preservation stage. Sometimes they're simply disposed of, and we talked about that in the learning module on lifecycle development. Now, each stage in the life of a file has three phases of development. One that's kind of commonly overlooked is the design stage. Oftentimes we kind of take the design of how we're going to store a file for granted and charge right on to creating the content for the file. But it's important, especially with more complex types of application output, like for video, graphics, research data, etc., to actually design the container that the specifications for the container that is going to contain your data output. The second phase is the creation phase, where data and content is generated and stored in the files. And then the third phase is that once you have a whole bunch of files that have been generated, you need to manage those in some way to make sure that you can store them and retrieve them, and then take the elements, prepare the element files to be put together to create finished product files. And here we see the three phases of each of the life stages circled in red. Now, in the design phase of file management, as I mentioned, it's important to define the characteristics of whatever container file you're going to use for the content that you are producing. So, three considerations before you start producing information for a new project. We could use the term paper idea again. Before you start writing your term paper, consider what kind of extended properties you'll need to document the Word document file that you're going to use. Are you going to turn on version tracking? That's kind of important to do before you start writing the paper. Are you going to write internal notes and make internal markers inside the Word document? And if so, are you writing them specifically for your own use, or are you going to write them so that other people might be able to view them? And if so, then you'll need to write them in a form that other people find usable. Data fidelity is another aspect of file design. So especially if you're going to scan a document or a photograph, you'll need to determine in advance what you want the resolution and bit depth of the image to be before you start scanning away. You'll also need to determine what kind of format you want to capture the file in. Do you want to capture it in a completely uncompressed format or a compressed format? So the quality of the data capture is often, in certain types of applications, very important to decide in advance of starting to create the content. And then need to decide before you start producing content how accessible the content needs to be. For example, do you need to use a format that is specifically readable by an intended user audience? In the case of your term paper, you would want to produce your paper in a format that the instructor can read, certainly, which might be Microsoft Word or the OpenOffice document format. But perhaps turning in your term paper in a plain text format would be a bit too much accessibility. Text document format is the most open and accessible format to use, but it also lacks formatting capability. And so for a published report or a scholarly article or a research paper for a class, plain text format is not appropriate. And something like Microsoft Word document format is appropriate for the immediate intended use, but if you intend to preserve your research paper long term, once you've written it in Microsoft Word, then you might wish to convert it to a text format for preservation purposes. And third, I should mention, with a lot of complicated, sophisticated software, again, such as data analysis, data capture, media production software, it's often necessary to maintain a copy of the software in the archive long term so that you can reconstitute, you're guaranteed to be able to reconstitute the content files several years down the road after that the version of the software that produced the files is no longer available. It's very tough to really recommend specific formats to use for long-term, to maintain long-term accessibility, other than things like uncompressed TIFF format for images, uncompressed AVI format for video, and text format for documents, which are good long-term preservation formats. File formats are typically very much in flux, even open source and open access file formats, such as are used by OpenOffice. So the watchword with trying to decide long-term accessibility is often not to pick a format from the outset at the point of creation, but to maintain some vigilance over your files, and as the years move on, to actually continue to convert them into more current formats later on. And we'll talk about this in a lot more detail later in the preservation module in the course. So let's finish up by talking about when you design files for production, at the outset of a project or an assignment, before you start creating the content for your files, these are the three main priorities. First is to design your file container for its intended distribution. And like I talked about just previously, for a term paper, submitting it in plain text form probably isn't going to get you an A on the paper, but submitting it in the proper format, Word document, with including formatting of the paper and style guidelines and so forth, definitely are more appropriate to the intended audience of your research paper. The second consideration is to design your content for reuse, and think about, once you've created the content, can you later revise and update it easily? This is particularly important in media and graphics production. A lot of media products, media authoring products, once you output the final form of the content, such as a movie, digital movie, or digital graphic, those files are pretty much locked so that they can't really be edited again, and you would have to recreate them from scratch. So it's important to design them, for example, in Photoshop, to design your images with layers rather than to design them as flat images. The same thing goes with audio and video editing. And certainly in data analysis, when you have to transform data into readable information, a lot of the original characteristics of the data can be lost. So it's important to be able to design the files to be reused, or to maintain all of the original element files that went into creating the final product, so that you can go back and easily make changes to and create a new version of the final output. And then, as we just talked about in some detail, to design your your files for preservation purposes and make sure that they are going to be accessible in 3 to 5 years from now at the minimum. So let's talk a little bit here at the end about this week's assignments. We just got done with the lecture. I'm sure you've seen the introduction. We've got 4 assigned readings. I assigned one really good, it's a great chapter actually, on digital object formats, which talks a lot in more technical depth about what format files you should choose for specific purposes. There's another chapter that I included on how to manage manual filing systems. And the chapter was designed to talk about paper-based information, but actually managing files is a lot like managing paper in a number of respects still. There's a lot fewer of us that have to do it. There's not so many, there's not any file clerks anymore. At least you rarely see them. But the insights in that chapter, in case you're wondering why it was assigned, are important to think about in terms of how we apply those principles of manual filing systems to digital filing our digital objects for access and use. There's also an older article on how to document a spreadsheet, which is excellent because the author talks a lot about preparing and designing the spreadsheet file for use by an intended audience, kind of as we've covered in the lecture here. But that's a specific application, which was, I think, a very good example. Since we have a shorter week, we got sort of off track last week with the extended assignment, which was a larger, a heavier duty assignment anyway. So this week we've just got a tools and methods assignment, which I think you'll find enjoyable, which I want you to try out 3 different file management applications. I've given you a list of some. I want you to go find another of your own. Just make sure you find the software that you're going to pick on your own from a safe software archive, something that's well known and isn't going to try to install some sort of malware on your PC. But do be careful with that. And then I'd like you all to post your to write reviews of the software that you looked at, the 3 applications, and then in the end there to read your classmates' software reviews and to make at least 3 discussion postings. So tools and methods assignment is due on the 23rd, that's Sunday, and next Tuesday the discussion postings are due. So please let me know if you have questions or comments, and especially let me know if you need any help with installing the software applications and using them, or if you need help identifying a safe online software archive to choose your 3rd file management tool from. And other than that, please have a great week. I'll talk to you later. Bye.